All right, so Chapter 8, Lesson 4 is multiple representations of functions. So, what kind of representations have we already seen with functions? We've already seen them written as equations, right? Tables, function tables, good. We've seen them in a graph. And we've also seen them written as words. So, as a matter of fact, this Chapter 8, Lesson 4 is pretty much a review of everything that we've done this week. Okay? All right. So, in the warm-up, it says, a group of friends are going to the museum. Each friend must pay an admission price of $9. So, the first thing we want to do is complete the table, the function table here, and then graph the ordered pairs right here, and it's the x comma y is going to be the number of friends, comma, the total cost. So, if we have one friend going, it's $9. If we have two friends going, it's 18. 3 friends, 27, and 4 friends, 36. Very good. So now when we graph, what's my first ordered pair? 1 comma 9. How about the next one? 2 comma 18. How about the next one? 327 and 4 comma 36. And there is what your graph looks like. Now, if we connected our plotted points, what does the graph look like? It looks like a straight line. Does everybody see that? Straight line. Now, because it's a straight line, we call it a linear equation, linear function. Very good. So, the ordered pairs lie on a straight line, and that makes this a linear function or a linear equation. Good. Now, looking at this function table, we want to write an equation to find the total cost n tickets. We want to write the equation. So, each time, what am I adding to here? I'm adding 9 to each time, so what am I going to do with that 9? You're going to multiply it times x. Very good. So, y is equal to 9 times x. Okay? We could put 9 times n because they said to use the variable n tickets, but that's all right. So, we want to list the ordered pair for the cost when 5 friends go to the museum. So, if our equation is y is equal to 9 times x, if 5 friends go, how much is it going to cost total? $45. So, our ordered pair would be what? 5 comma 45. Very good. Is everybody clear? Awesome. So, like I said, we are going to represent functions in different ways. So here we have functions represented in words and as an equation. So in words, the example says a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. Okay? So if I look in the words, you see the equation. It says distance is equal to 8 miles per hour times the number of hours. Does everybody see the equation? Yeah. So distance, D, is equal to 8 miles per hour times, there's the times because there's no space in there, times the number of hours, times T. All right, here it says, words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what variables to use to represent the different quantities. And what they mean by that is like up here, so D was distance, right? The number of hours was the T for time. Does that make sense? So you need to make sure that your variables make sense to the problem. Okay? All right, so for the two examples here, we have the drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned, T, for selling P pies. So first thing we see here, they've already told us what the variables are, right? So they're telling us that T is going to be the total amount earned, and P is going to be for the number of pies they sold. Okay? If we look up in the problem here, it says they are charging $5 for each pie they sell. $5 for each pie they sell. What word in that phrase tells me the operation? Each. And of course, each means that we're going to multiply, right? So here in words, we have the total earned equals 5 times the number of pies sold. So then we're going to define our variables. We defined T and P as our variables. And now we have our equation. So the total amount they earned is equal to $5 times the number of pies they sold. Does everybody see how the English turns into the math?
Yes.
Okay? So our final equation is T is equal to 5P. All right. Example 2 says, in a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B a non-active person takes in M minutes. Okay? So when we look at this, our variables, if we define our variables, you can see that B is going to be what? Total breaths. And then M is going to be minutes. So there they've already given us our variables, right? So B is equal to the total breaths, and M represents the number of minutes. Now, looking up in the problem, it says right here, the average adult breathes 14 times each minute, right? So that's going to be the number of breaths, 14, times the number of minutes, whatever those minutes might be. And so here is where we have that important information. The number of total breaths equals 14 times the number of minutes. So now we can change that to an equation. So the total breaths equals 14 times, so 14 times the number of minutes. And there it is right there. So the first one, example A, says a mouse can travel 8 miles per hour. Write an equation to find the total distance D a mouse can travel in H hours. All right, so let's write down some important information, okay? So what, or we'll underline some important information. You guys will write it down. What are our variables going to be?
D for distance.
All right.
Hours.
Good. So D is going to be the total distance, and H is the number of hours. Very good. So if I look in the words again, it says a mouse can travel 8 miles per hour, right? So if I want to write this in words, what would we say? So the total distance is equal to 8 miles per hour times the number of hours. Okay? So what's my equation going to be? D equals 8 times h. Very good. There it is right there. D is equal to 8 times h. Example B says Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies, C, that she can make in h hours. So the first thing we want to do is define our variables. All right. So what are our variables? What do you think?
C for cookies, H for hours.
All right. So we've got C for the total number of cookies, and we have H for the number of hours that she's going to be baking, right? So now we want to look at the words again. Look up there and see what's going to tell us our expression. Well, Samantha can make
36 cookies.
each hour. And what does each mean? Multiply. Very good. So what is my sentence going to be? What is my function in words going to be? Yes.
Total number of cookies is equal to 36 cookies times the number of hours.
Very good. Very good. Let's type that out. So we've got total cookies is equal to 36 cookies times the number of hours. So what is our equation going to be?
Equals 36.
Very good. C equals 36 times H. All right, so now we want to represent functions using tables and graphs. Now, we've already seen them in a function table, and we've already seen a function in a graph. So again, this is just a continuing review, right? So, you guys, this is what the function table looks like, and this is what the graph looks like. You need to know that you can represent a function in 4 different ways. You can use words, right? You can use an equation. You can use a function table. And you can use a graph to represent functions. Is everybody clear? All right. Okay, so let's look at the next example. Once again, you don't have to write this down because we're just going to talk about it. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. Write an equation and make a function table to show the relationship between the number of cars washed and the total number and the total amount earned, T. So, once again, there's our variables. So we've got the number of cars washed, that's C, and the total amount earned, T. Okay? Then, if you look in the words again, just like we did previously, it says they are charging $7 for each car they wash. And that's going to give us the total. Okay? So, the equation is T total is equal to $7 times the number of cars they washed. So, T is equal to 7C. Is everybody clear how we got the equation? So now we're going to create a function table to show that data. Now, remember with the function table, you can choose any numbers you want to. But let me ask you this. In this particular problem, would I use 1.5? No, because they're not going to wash 1.5 cars. Right? They're just going to wash 1 car, 2 car, 3 car, 4 cars, right? Does that make sense? All right, so here we can only use 1, 2, 3, and 4. All right, so when you put the 1, 2, 3, and 4 in there, and then you substitute and simplify, this gives you the total amount earned. Got it? All right, so once you have this function table, what can I do? We can graph it, which is what we're going to do down here. Okay? So, we're going to graph the ordered pairs. What's my first ordered pair?
1,
Comma, 7. The next one is
2, 14,
2, comma, 14. And the next one?
3, 21,
And the next one.
4, 28.
Very good. And there they are right there. So when we graph, this is what it looks like. Now let me ask you this. Would I connect the dots here?
I've asked you this question before.
Yes. So we do not connect the dots here because can they record washing half car to get in there? No. Wait, let me. So we cannot. Where's the red pen? Okay, so we're not going to be able to plot that point right there, right? We're not going to be able to plot 1.5, right? We're not going to be able to plot 2.5. We're not going to be able to plot those red points there, so we will not connect the dots. But do the points still lie on a straight line?
Yes.
Yes, they do. So is this a linear function?
Yes.
Yes, it is. Very good. All right, so while in normal flight, a bald eagle flies an average speed of 30 miles per hour. So we're going to do the same thing that we did with the car wash. We want to write an equation and make a function table to show the relationship between the total distance d that a bald eagle can travel in h hours. So what are my variables? Very good. So d is the total distance and h for hours. Very good. So, what's the equation going to be? Oh, we got to look at that. We got to look at the words again to find out. So it says a bald eagle flies an average speed of 30 miles per hour, right? So now, what is my equation going to be? Yes.
D equals 30 times h.
Very good. D is equal to 30 times h, right? And then we're going to choose numbers to put into the function table. So we can choose, let's choose 1 hour, 2 hours, and 3 hours, okay? So 30 times 1 gives me 30. 30 times 2 gives me 60. And 30 times 3 gives me 90. Very good. So now we can graph it. So we've got 1 comma 30. We've got 2 comma 60. And we have 3 comma 90. Hold on. And that's our graph. Now let me ask you this. Will I connect the dots? We can do 0 comma 0 too. Well, let me see. Can that bald eagle fly for half an hour? Yes. So can I get here in this line right there? Can that bald eagle fly for an hour and a half? Yes. So because we answer yes to that question, we do draw the line, and then you can see again that this is a linear equation. Very good.